So one of the things that's very typical when you're working with lists, linked lists, is especially if you have doubly linked lists, but really the author's code will do it, and you may see this anyway. But one of the typical problems that we have with the linked list is that we always have this consideration of the front is not a node, right? Front is not a node. It's a reference to a node. And that's one of the reasons that we always have, perpetually have special cases for front. So some smart person along the way decided that maybe what we should do is make the situation all go away by simply making a dummy node at the start. And a dummy node would be something like you see here in this student, right? Where obviously these are all student nodes, right? Or in this case, they're all going to be, they're all going to be nodes. Whether they're generic or not, it doesn't make any difference. But the idea is here that what front would point to would be this node, but this node is not intended to be real data. It's intended to be a buffer, right? It would always have data being null. It is not intended to contain real data. It's just a placeholder. And so at the front of the list, you'd have this dummy node, because that way front always points to a node and you can always follow that pointer, right? You never worry about, is front null, so I can't take a step. You can always take a step because there's always a dummy node. When you create the thing from the very start, you make that dummy node. You said it's dated to null, you said it's next to null, but then you know that whatever else you're going to do, you're always going to be on a node from the start, right? So what that does, and you can do this if you have a doubly linked list, you might have a dummy at the front and you'll have a dummy at the end as well, right? You have one on either end because front points over here and end points over here. So that way you always are clean. So let me show you the difference in the code. So notice in this case, if we're saying add at position, one of the things that we do here is, let's say we take in the position and then you pass the thing that you want to put in, let's say a student or whatever, right? In this case, we will have this code that says if front equals null, then point front to a newly created student, right? So we'll always have this extra little bit of code. And then if it's not at the front, then we can go ahead and move to the next spot and we can follow that front reference and actually move forward. But notice the code, if we are using a dummy node, all of that if code goes away. We start current and we can just march, right? Now, we're going to want to verify that we're not going to march too far. We're going to want to have preconditions, yes. But notice that we have no code now that checks for an empty list, because in truth, the list is never empty, right? There's always a dummy node there. So you can always start marching and move forward. Actually, I think the preconditions are going to be in something like get node at, right? But in this case, all of that special casing code goes away. You just have to remember that you always have to move in one, right? You're always going to start at that point, and then you're going to start your operations at that moment. Okay, so it really doesn't make life any more difficult. It just means that you have to just gets a little simpler, right? So your author, if you look at the author's code, that will be a doubly linked list, and it will have dummy nodes on either end. Okay. So it's really just for code, for code simplicity, and based on the things that we were just talking about. So does that make sense? All right. You don't need to do that for your project. I actually think a dummy node would be problematic in our project. So for project 4, when you go to make your lists, I would not use a dummy node. Because for a circular linked list, as we'll see, you really don't want there to be anything in the way. You just want to be able to go round and round and get the next thing, right? So we actually don't want a dummy node. We just don't want to worry about it, right? So I wouldn't use this in the project, but it's an interesting thing, and you will see it if you're trying to adapt the author's code, which I suggest you don't do. But if you were looking at the code to do something, you just have to realize the dummy node thing is a real thing. Okay. All right. So now we're just going to cover a couple of hints. We're going to talk about some variants, and then we'll jump over and talk about project 4 a little bit. So a couple of hints here. If you're going to write your own code, especially, which I highly encourage you to do for this project, remember that testing is critical. Your algorithms are going to be right in several cases, but not in all cases. You always want to think about, what if the list is empty, right? If I'm starting on an empty list, that's almost always a special case. So you always want to test your stuff. Every method you write, using an empty list to make sure it's going to behave properly. Also, if you're looking for certain nodes or certain scenarios, you always want to think about, what if the thing of interest is at the start of the list? What if the thing of interest is somewhere in the middle? Or what if the thing of interest is at the end? Does my code work properly in all of those positions? So again, if I were thinking of something like add at position, I would say, can I add at the front of the list? Can I add somewhere in the middle? Can I add at the end? And is everything intact and perfect in all of those scenarios? And I would try an empty case, right? I always want to start with an empty list and see if I can add at a position of position 0, let's say, at the in an empty list. So always think here about testing. You will suffer